Hello friends, today we'll study a topic that is capacitance of a parallel plate capacitor. So, what is a parallel plate capacitor? So, a capacitor in which both the plates are parallel to each other is called a parallel plate capacitor. Even though we'll solve a question in which both the plates are not parallel to each other, they are inclined at certain angle. So here we'll move forward with the steady state of a parallel plate capacitor. So let's suppose these two are the plate of capacitor separated by a distance d. From this side they are connected with a battery. At the steady state, this plate is having plus q charge and this plate is having a minus q charge. We already know that at this case the positive charge will reside in the inner surface of the plate. So I am drawing here, and negative charge will reside in this inside surface of the plate. Now both the charges, positive and negative charge, these will produce electric field. Positive charge will produce electric field in a direction away from it equal to sigma upon 2 epsilon naught, and this negative charge will also produce a field in direction of it, that is sigma upon 2 epsilon naught. These are the electric field due to positive plate and due to negative plate. Now the net electric field between both the plate will be addition of these two, that is sigma upon epsilon naught. Now what is sigma? Sigma is the charge per unit area. We can also say it is charge density. Now we have studied Q is equal to C into V. So we can write C as Q upon delta V, where delta V is the potential difference between both the plates. Now we can write the potential difference as E dot D, the distance between both the plate. The electric field here between the plate is uniform, that's why we are not integrating it, we are simply writing it as E dot D. Now the electric field between both the plates is sigma upon epsilon naught into D. This is the potential difference between the plates. Now sigma is charge per unit area, that means Q upon A, epsilon naught into D. This is potential difference. Now if we put this here, we can assume it as first equation. So we can rewrite C is equal to Q upon Q A epsilon naught into D. In this expression, Q gets cancelled out and we get C is equal to epsilon naught A upon D. Now if we pay attention toward this expression, then we'll see that the capacitance depends on area and the distance between the plate. So here we can say the capacitance of a parallel plate capacitor depends on its geometry, and epsilon naught suggests that it also depends on the medium between the plates. Here we see that the charge gets cancelled out. That means the capacitance of this capacitor does not depend on the charge it acquires or the potential difference between the plate. It only depends on geometry and medium. Now we'll move toward a question on this parallel plate capacitor in which both the plate are not parallel to each other. They are at certain angle. But we'll use this very formula or this very expression in solving that question. So the question is, there are two plates and both the plate are having same area. This is first plate and this is the second plate. Here the distance between both the plate is y naught, and toward this end this is y naught and this is also y naught. That means here the distance between the plate is y naught, whereas here the distance is 2y naught. Now the length of plate is A and the width of plate is B. In this particular question, medium between both the plate is vacuum. We'll consider epsilon naught over here. Now the question is find the capacitance of this setup. So here we can see the distance between the plates are variable. Okay, so if the distance between both the plate are variable, then in the expression C is equal to epsilon naught A upon D, we get this D as variable, and if we get a variable, we have to use integration. So for integration, from this end at a distance x, I am considering a section that is dx. The width of this section is dx. If I select this region, then this is the section which gets selected. Now I will treat this selected region as a capacitor, where this is the area between the plate, and this area is B into dx. And here I have to find this distance. Let me say it is at D. So we have to find the whole distance from here to here. So how we'll find? This is angle theta. If I try to write tan theta, then we can write it as, in this bigger triangle, I can write y naught upon A is equal to, in this smaller triangle, I can write it as d upon x. From here, I can write d equal to y naught A into x. So this distance, I have got this distance which is in the y-axis direction in terms of x-axis direction. For only we have got one variable, that is x. That's why I have converted this height in the direction x. Now small capacitance of this selected capacitor will be epsilon naught into the area of plate. This area is, here the length is B and this width is dx. Therefore area will be B dx upon. Now I have to write this distance. So we know this is y naught plus d. And what is d? D is y naught upon A into x. So I can write this distance as y naught plus y naught upon A into x. Now the integration of this term will give us the capacitance of this setup. So what is the variable? That is x. Its limit will be 0 to A. So the limit is 0 to A. First of all, we'll write epsilon naught and B out of the integration side, epsilon naught B, and we will integrate dx upon y naught plus y naught upon A dot x, limit 0 to A. So the integration of this expression comes out to be C is equal to epsilon naught B, and this is log y naught plus y naught upon A into x, and in denominator we will get y naught upon A. Okay, and the limit of this will be 0 to A. Now we are taking this term out of the bracket. So C is equal to epsilon naught. This A will come at the numerator, B upon y naught. Now first we'll put the upper limit and then we'll put the lower limit. Now I am writing upper limit log. I will put A, then we'll get y naught plus y naught upon a, and at the place of x I am writing a. Now we know that log a minus b is equal to log a upon b. So if I have to write minus with the limit of 0, I can write it as division. So if I put this 0 at the place of x, I will get y naught. So log a minus b, I have written it as log a upon b. Now this a will cancel out. In the numerator there will be 2 y naught, and denominator is y naught. So I will end up with a expression that is epsilon naught ab upon y naught into log 2. So this is the expression for the capacitance of this setup. Now few things we can understand with this setup is, if I am connecting this capacitor with a battery, so the battery is having a potential V. So the potential difference V should be uniform at every place. If here is 0, then here the potential is V. If here the potential is 0, here the potential is V. So the potential difference will be same. So what is the scenario in this question? What is changing? If the distance d is changing, we know delta V is equal to E dot T. Delta V, the potential difference between the plate, has to be constant at a steady state connected with battery. So if D is increasing, then electric field should be decreasing. Here the distance is minimum, therefore the required electric field is maximum. Whereas in this case, at this end, the distance is maximum, that's why electric field should be minimum. From this we can conclude that at this place where the distance between both the plate is less, there the number of charges more. Okay, the distance between the plate is minimum, then it will have more charge, and where the distance is larger there will be less charge, just so that the potential across each cross section is equal. Thank you.